Yo, welcome to the part 3 of Groth16 verification. I'm Shami and this is Advanced Cairo. So right now our pairs share the final exponentiation. What we would like to happen is that within the Miller loop, we also want all our pairs, three of them, to also share FQ12 squarings. And with that, like here are basically like to-do items. So the first one, which we're going to be working on in this video, is to create a suitable type to represent Groth16 proof. So let's get started. So this is our test. I've already created this verifier.cairo inside Groth16. So I'll go ahead and copy all these imports over to verifier because we're going to be doing the same stuff. So we're going to need the same imports that this is using. Then let's start with our struct. So looking at our Miller loop. Oh, one difference you'll see here that now I've also added TG2 to the Miller steps. I'll share a link to the commit if you want to see what exactly is changed, but this actually helps things to be more structured for TG2 being, like a multi-point tuple kind of a thing. So, all right, so we see here that for Miller pre-compute, it needs TG1, TG2, and that is also what we're going to pass to our 8 Miller loop. So let's start by defining our equivalence of TG1 and TG2. Let's say struct, and we're going to say, we're going to remove T, and we're going to say Groth16 Miller TG1 and TG2. So here we can say that we want the points in G1 and G2 respectively. Now let's go over to test over here and see that we have alpha, beta, gamma, and delta, but we also have alpha, beta, Miller, so we can skip out on alpha and beta. So we've got gamma and delta from here, and we also want pi a, b, c, and just for the Miller part, we're gonna not take public input, but we're gonna take k directly. So let's go ahead and copy all these things from all these points from here, and pi a, pi b, pi c, and k as well. So I'll copy all these and we go to our struct and we try to paste everything here. And so gamma, delta, and pi c are going to be points in G2. So let's set that type over here. And pi a, pi b, and pi a, pi b, and k are going to be points in G1. So there we go. Now let's move the points in G1 over to G1 area and there we go, and G2 to the G2 area. Cool. So these are our two types for the pairing part of the Groth16 verification. There are other parts, like we can see in tests we're doing this multiplication, we're doing this processing of input constraints, but this we will not implement it in our traits. This will be handled separately in a separate function. That function will still reside in verifier to keep everything together. So with that, our first objective is done. In the next video, we'll figure out what our pre-computed orgs should look like. So I'll see you in that one.